Polio is a virus that spread rapidly due to its transmission through airborne pathogens. Therefore, polio can be spread through things as simple as talking. Due to its lacking signs and symptoms, it is often discovered later in its development. This stresses the importance of the polio vaccine for the immunization of individuals. Pathogens such as poliovirus contain certain chemicals that are foreign to the body, called antigens. White blood cells, called lymphocytes, carry a specific antibody. The antibody has a protein that has a chemical that can fit to certain antigens. When a lymphocyte with the appropriate antibody meets a foreign body, it will reproduce quickly, making copies of the antibody that can neutralize the pathogen. Antibodies can neutralize pathogens in a number of ways. They can bind to the pathogen, they can coat pathogens to then be ingested by phagocytes, or they can bind to pathogens and send out chemical signals to attract more phagocytes to the affected area. The macrophages will be attracted by the death of neutrophils. These cells attempt to engulf pathogens whilst also sending signals to other cells for help. Plasma B cells produce antibody molecules that are released into the blood and lymph, where they bind to targeted antigens, allowing for neutralizing and destruction. The dendritic cells, which are constantly scouting around whilst communicating to up to 200 other cells, may find the pathogen, taking a piece to present to the helper C cells that congregate in the lymph nodes of the body. If the helper T cell recognizes the invader as one of its antigens, it will release cytokines, alerting other helper T cells as well as B cells, which will then immediately clone and increase in number. The helper T cell then activates the appropriate immune cells for the attack of the antigen. If the invaded organism is a virus such as polio, the helper T cell will signal the cytotoxic T cells to come to the rescue. These cells punch holes in the walls of invading virus infecting host cells, killing the cells and destroying the virus. Cells can also be activated to produce antibodies that will stick to free viruses, marking them out so that the macrophages can come in and clean them up. A few days of being infected with the cell, the T suppressor cells will send out signals telling your immune system to calm down. The memory T and B cells will remember the specific antigen for if you ever meet the specific disease in the future. The inactivated poliovirus vaccine is often referred to as IPV. IPV is often injected into the arm or leg depending on the patient's age. The vaccine may be given at the same time as other vaccines, but most people should be given it as children. Children get 4 doses of IPV at these ages: 2 months, 4 months, 6 to 18 months, and 4 to 6 years for a booster dose. Inactivated vaccines use dead versions of the germ that causes the disease, such as polio. Inactivated vaccines often protect rather than lead to immunity. Hence, the need for booster shots to gain ongoing immunity are needed. Inactivated vaccines are not the most effective, but the inactivation process does not affect the immunogenicity, the ability for the organism to produce an immune response in the host. When viruses enter our body, our lymphocytes produce antibodies to kill foreign invaders. It takes our bodies several days to produce antibody responses to new antigens. Antibodies see the dead virus that was injected as a threat before producing antigens. Therefore, the memory T and B cells can remember the characteristics of the antibody, thus being able to create antigens quickly if the antibody ever became present in the host. The more people vaccinated in a community allows for the reduced risk of the spread of disease. This is called herd immunity. For herd immunity to be effective for poliovirus, between 80 to 85% of the population would need to be vaccinated for it to be fully effective. Thank you for listening to my presentation on the polio virus and the effects that it has on the populations, hence showing why it is vital for vaccinations to occur. Thank you.